are showcasing nature-inspired solutions for connected autonomous vehicles. We want to convene people from industry and academia to learn about technologies and to find solutions for problems that are big challenges in industry.
The third wave AI is going back, looking at brains of real animals, figuring out how they solve problems, figuring out how we can get their efficiency and get that into engineered artifacts.
We're interested today to find out how we can actually adopt some of the instincts from animal insects to be able to incorporate those into some of the technology projects we're working on.
Nature has, over the course of evolution, developed incredibly efficient and robust solutions to many of the problems we want to solve for autonomy and for data processing. And what we want to do is take those solutions from nature, reverse engineer them, and then create technological solutions that we can then use in the modern world. Honeybees use optic flow, the way things move around them, in order to navigate and find their way in the world. And as such, it's incredibly important to them, so they have a highly refined sense of optic flow. So what we did is we looked at how the neurobiology of the honeybee was laid out. We looked at the information from neural recordings about what kind of signals are present. And then what we've done is use that data to construct an algorithm that captures how honeybees solve optic flow.
So of course this is precisely what nature-inspired solutions are all about. Going back, mining algorithms from nature and understanding how they work so we can implement them in our own devices for our own purposes.
We design algorithms that coordinate mobile autonomous robots, mobile autonomous entities in order to create collectively intelligent systems. Currently, the way drivers drive on highways is they have no knowledge of what the traffic around them is doing, so it's completely non-communicative. It's entirely egocentric, so every driver has his or her individual idea of where he or she would like to go, and obviously we want to get there as quickly as possible. And that has repercussions on traffic, clearly. So we have traffic jams, we have bottlenecks, we have congestion, and my opinion is that this is all unnecessary. And what I showed you in the video is that with very, very subtle changes, with just the very slightest degree of cooperation, that is probably hardly perceptible on the individual driver level, we can actually remove bottlenecks entirely.
So what we have here is a mechanomyography-based system. We read the signals that are coming from a muscle, and we can then use those signals to control a prosthetic limb or a prosthetic arm or a robotic arm, which an amputee would wear.
And what we know about insects is that they have a fantastic panoramic vision. They can basically see in all the different directions, and that is extremely helpful if they want to assess whether they are rolling or pitching or doing a particular maneuver during flight, or in which way they have to compensate or rotate their head so that it's always aligned with the external horizon. An extension of the research we are doing is shown here with this little robotic platform. If you look a little bit closer, you can see there's a fly here, and we can use actually that fly as a sensor as we record the activity of a particular neuron in the brain that is indicating to the fly whether there's horizontal movement. Now you can imagine if the robot is moving in space, that this neuron will be excited and inhibited in a certain pattern. And that pattern we can exploit in a way so that a robot that is moving in space is not colliding with any obstacles.
Nature-inspired solutions is a broad church. There's people in all kinds of different disciplines, and the normal channels of communication don't necessarily work. So having a single place where everyone can come together and meet is essential.
It's been a very good meeting.